Hello there and welcome back. In this video today we're covering the quicksort algorithm. We'll be looking at what it is, we'll be looking at how it works, the exam pseudocode, and also its best and worst case scenario. So we're going to jump straight in. So the quicksort algorithm is like nothing we've seen before. The parts of it you might be familiar with. So for example, the quicksort algorithm is a divide and conquer algorithm, which means it's very efficient. It repeats itself on partitions of an unordered list until we get down to just one single element. The job then is to build all those elements back up until we get a sorted list. So the first point of the algorithm is we have to select what we call a pivot point. And the pivot point is the single most important part of this algorithm. We compare all the numbers to the pivot point and we say if the numbers are less than the pivot point, we move all those numbers to the left hand side of it, and then if it's greater than, we move all of the larger numbers to the right hand side of the list. And once we've done this process the first time, we have two sublists, the less than sublist and the greater than sublists. And our job now is to reapply the same algorithm on those two sublists, and then we get sub-sublists, and we keep going until we reach one single element, and we call that our base case. You might have heard those words before. We use them in recursive functions. And if you remember what recursion is a function that calls itself within itself until a base case or terminating condition is met. Okay, so let's have a look at the algorithm in action. The first step is to pick the pivot point, and in this case we're going to pick the number 3 because it's the middle number. Then we compare every element to it, so that we start with 9. 9 is greater than 3, so we place that on the right hand side of 3. 2 is less than 3, so we place it on the left hand side. 6 on the right hand side. 5 also right hand side. And notice there's no order to where we place it when we're putting it into sublists. 4 is greater than, so it goes on the right hand side. 7 is also greater than, right hand side. 1 is less than 3, so it goes on the left hand side. And then 8 finally goes on the right hand side. So that's the algorithm in its first iteration. Now at this point, we then break the list down into two sublists. We then run the same algorithm. So we pick the middle number. Now you can either pick the upper bound of that number and round up or round down. As long as you're consistent through each step, it's always the same. 2 is greater than 1, so it's on the right hand side. And then we've broken it down to our single elements and they are completely sorted. Then we start on this subarray. The middle point is chosen again. 9 is compared to 5. 9 is greater than 5, so it goes on the right hand side. 6 is greater than 5, so it goes on the right hand side. 4 is less than 5, so it goes on the left hand side. And 7 and 8 are both greater than 5, so they go on the right hand side. So you can see now that the algorithm is just repeating itself over and over again on different sublists. Looking at 4, we run the algorithm, but it's a single element, so we know that is sorted already. So we choose 6 in this case, compare 9. It's greater than 6, so it goes on the right hand side. 7 is also greater than 6, so it goes on the right hand side. And 8 is greater than 7, so it goes on the right hand side. Then we choose 7 as the midpoint. We compare 9 to 7, it's greater than 7, so it goes on the right hand side. And so is 8. In the final list, we choose the number 9 and compare every element to it. We've only got one left, which is 8. So we compare 8 to 9, and that's less than 9. And finally, 8 is a single number, so we know that's sorted. The only thing left now is to recompile the list, and you'll see that our list now is sorted. Now the algorithm's done, we now need to look at the pseudocode for this question. Now this and all my examples are all from exam papers from the Eduqas exam board. So all I'm going to do today is dry run this algorithm, showing you the example that we just previously looked at and how this would work in an algorithmic approach using pseudocode. The first thing to point out is that we have to declare a procedure or a function. So here I've got a quicksort and I've got a few parameters, the things in between the brackets. I've got an array of, it says strings, but the question was aimed around an array of strings. So I'm going to focus, because our example was on integers, I'm going to focus on integers today. We then pass in the index low and the index high. That's the bottom of your array and the top of your array also. I've got a few variables. I've got pivot, temp swap, temp low, temp high, and index low and index high for my parameters. The first thing I'm going to do is set my index low and my index high equal to the bottom and top of my array. Further on down, I've got temp low is assigned the value of index low and temp high is assigned the value of index high. So that really sets my pointers. I work out my pivot point, which is my array, which is cast to an integer. I've got index low, which is 0 plus 8, which is 8 in total, divided by 2 equals 4. So that gives me index position 4 is my pivot point. And at index position 4 is the number 3. The next thing I need to do is evaluate my first while loop. So while temp low, which is 0, is less than or equal to 8, that's true. So we go inside that and evaluate the next while loop. While my array at temp low, so temp low is 0 and that gives me the value of 9. While that is less than the pivot point, which is 3, and temp low, which is 0, is less than 8, because that's index high. We fail that condition because 9 is not less than 3. So we move to our second while loop, while the pivot, which is 3, is less than my array at temp high, which is 8, and that gives us the value of 8, and temp high, which is 8, is greater than 0. So 3 is less than 8 and 8 is greater than 0. So we pass that condition. So we go inside the loop and it says temp high equals temp high minus 1. So this line here actually decrements the pointer in the array. So I need to set my temp high variable from 8 to 7. And because we're in a while loop, we have to go back up and reevaluate the condition. So now we say while the pivot point of 3 is less than whatever's at position 7, because that is temp high, that gives us the value of 1, and 7 is greater than 0, we actually fail that condition because 3 is not less than 1. So now we skip on and evaluate the if statement. It says if temp low, which is 0, is less than or equal to temp high, which is 7, and that turns out to be true. So we're going to go inside and actually do a swap. The temp swap variable is assigned whatever's at my array at the position of temp low. Temp low is 0, so that means 9 is placed into temp swap. My array at temp low, which is position 0 in my array, is given the value of whatever the value is at temp high. So 1 is placed and overwritten the number 9. Then number 1 at the top of my array in position 7 gets given the value of temp swap, which holds the value of 9. And once we've done the swaps in my array, I have to decrement my high pointer and increment my low pointer. So the 2 pointers get closer together in the array. Now we've completed the if statement, we have to hit the while end part of my condition. So I have to jump back up to the while loop at the top and I have to start my conditions again and say while temp low is less than or equal to temp high, and temp low currently has the value of 1 and temp high has the current value of 6. So 1 is less than or equal to 6, so I go inside and evaluate the first while condition inside. And that says while my array at temp low has the value of 1, so now I'm looking at the value of 2. While 2 is less than the pivot point of 3, and temp low, which is 1, is less than index high, which has the current value of 8. That is true. 2 is less than 3, so I keep it already in its position on the left-hand side of the array, and all I need to do is increment my low pointer by 1. Again, because I'm in a while loop, I evaluate the condition now, so I say while my array at temp low being 2, that gives me the value of 6. While 6 is less than 3, already I know that's going to fail because 6 is not less than 3. So we fail that while loop, and then I move down to the second one and say while the pivot point of 3 is less than my array at temp high. Temp high has a current value of 6, which gives me the value in my array of 7. So while 3 is less than 7, which is true, and temp high, which is 6, is greater than 0, which is true also, all we have to do here is decrement the pointer. And we do that on the line that says temp high equals temp high minus 1. So I decrement my temp high pointer to 5. Again, I've got to reevaluate the while condition. So I say while the pivot point, which is 3, is less than my array at temp high, which is 5, gives me the array value of 4, and temp high, which is 5, is greater than index low, which is 0. 3 is less than 4, and 5 is greater than 0. So again, we have to decrement the pointer. So we change temp high's value from 5 down to 4. Once completed, we say while the pivot point of 3 is less than the value at my array temp high, which is also 3. So 3 is not less than 3. So I already know this is going to fail. So the while loop fails its condition, and then I break out and move to the if statement. If temp low, which is 2, is less than or equal to temp high, which is 4, which is true. So we move inside the if statement and we say temp swap is now given the value of 6. Because my array at temp low, which is 2, has the value of 6. My array at temp low is then given my array temp high, so 3 is placed in position number 2 in my array. My array at temp high is given the value of swap, so where 3 was before, 6 is now placed in that position. Once we've done that, then temp low is incremented by 1 and temp high is decremented by 1. That means the pointers point to the same location in my array. Now we've completed the swap, we hit the while end loop. So we jump back up to where it says while temp low is less than or equal to temp high. And we evaluate that condition. And we're checking to see if temp low, which is 3, is less than or equal to temp high, which is also 3. And they're equal to each other, so we pass that condition. So we move inside and evaluate the first while loop. While my array at the position of temp low is 3, so 5 is at the position of 3. Is that less than the pivot point? No, it's not, because the pivot point is still the number 3. So we fail that condition and move on to the second while loop. And we say while the pivot of 3 is less than my array at temp high. Temp high is also 3, so that gives me the value of 5. 3 is less than 5. So we check and say, and temp high is greater than index low. Temp high is 3, index low is 0, so 3 is greater than 0, so both of those conditions pass, which means the while loop passes, and we run the code inside that. That says temp high equals temp high minus 1. So we decrement the temp high pointer again, which now is 2. Again, because this is a while loop, we have to evaluate the condition, so we reevaluate the conditions again. While the pivot point of 3 is less than my array at temp high is now 2, so that gives us the value of 3. 3 is not less than 3, so we fail that condition. We move down to the if statement and say if 3, which is temp low, is less than or equal to temp high, which is 2, and it fails that condition. So we've jumped down to the while end, and then we jump back up to reevaluate the condition that says while temp low, which is 3, is less than or equal to 2, because that is temp high. So we fail that condition. So we've broken out of the loop altogether. We move down to the two selection statements at the bottom of the code. The first one says if index low is less than temp high. Well, index low is currently 0 and temp high is currently 2. So that is true. Index low is less than temp high. So then it says quicksort, which is the name of my procedure here. So it's saying run the procedure again inside this code, and that is recursive. And we're going to pass it some parameters. We're going to pass it the full array itself, which is called my array, and then we're going to pass it index low. Well, my current value of index low is 0, and then it says temp high. Well, my value of temp high is 2. So look what we're actually passing here. We're passing it an array from position 0 to position 2, which is the lower part of my array. Where the pivot is, all the numbers on the left-hand side of the pivot are less than it, and all the numbers on the right-hand side of the pivot are greater than it. So in this first iteration, we are actually passing the correct values. We have created subarrays here, because if we look at the next selection statement, we're passing in temp low, which is 3, and index high, which is 8, which is the upper bound of my array. So I'm not going to continue any further than that. That was just one iteration of the quicksort. The same algorithm applies on the next iteration on each sublist, and then we keep going until we reach just one value. And because we're using recursion and it goes onto a call stack, it's all reassembled back together. The only thing that we've got to look at now for the quicksort is the best and worst case scenario. So what would be the best case on the worst case for running this algorithm? The best case scenario for the quicksort occurs when the partition process always picks the middle element as the pivot. This means that all the numbers less than the pivot are already on the left hand side, and all the numbers greater than the pivot are already on the right hand side. So no swapping has to occur. The worst case scenario occurs when the partition process always picks the greatest or smallest element as the pivot. And this means that all of the greater than numbers will be all on the right hand side, and your pivot element will be the smallest number, for example, or the pivot point is the greatest number, the largest number, and that will go on the right hand side, and all of the rest of the numbers that you evaluate all have to move to the left hand side. And this means that when you partition your array, you have to run the algorithm again on lots of numbers. And you've not really saved much time, you've just removed one element from the list. And that's everything we need to know for the quicksort. Go back through this video, have a look, go back over things, take your time going through it, change the speed if you need to look at the animations or anything like that. I will timestamp the video so it's easier to navigate, but if you've got any questions, please do let me know.